An important point I want to make is that the results of an A-B test, even when you measure them in a principled manner using p-values, is not gospel. There are many effects that can actually skew the results of your experiment and cause you to make the wrong decision. So let's go through a few of those and let you know how to watch out for them. So let's talk about some gotchas with A-B tests. It sounds really official to say there's a p-value of 1%, meaning there's only a 1% chance that a given experiment was due to spurious results or random variation. But it's still not the be-all and end-all of measuring success for an experiment. There are many things that can skew or conflate your results that you need to be aware of. So even if you see a p-value that looks very encouraging, your experiment could still be lying to you. And you need to understand the things that can make that happen so you don't make the wrong decisions. Remember, correlation does not imply causation. Even with a well-designed experiment, all you can say is there is some probability that this effect was caused by this change you made. At the end of the day, there's always going to be a chance that there was no real effect, or you might even be measuring the wrong effect. It could still be random chance. There could be something else going on. It's your duty to make sure that the business owners understand that these experimental results need to be interpreted. They need to be one piece of their decision, right? It can't be the be-all and end-all that they base the decision on, because there is room for error in the results, and there are things that can skew those results. And at the end of the day, if there's some larger business objective to this change beyond, just driving short-term revenue, that needs to be taken into account as well. One problem is novelty effects. So kind of the Achilles heel of an A-B test is the short time frame over which they tend to be run. Okay, and this causes a couple of problems. First of all, if there are longer term effects to this change, you're not going to measure those. But also, there is a certain effect of just something being different on the website. So maybe your customers are used to seeing orange buttons all the time, and that blue button comes up and it catches their attention just because it's different. But as new customers come in who have never seen your website before, they don't notice that as being different. And over time, even your old customers get used to the new blue button. And it could very well be that if you were to make this same test a year later, there would be no difference. Or maybe there'd be the other way around. I could very easily see a situation where you test orange button versus blue button, and in the first 2 weeks, the blue button wins. People buy more because they are more attracted to it because it's different. But a year goes by, I could probably run another web lab that puts that blue button against an orange button, and the orange button would win. Again, simply because the orange button is different and it's new and it catches people's attention just for that reason alone. So for that reason, if you do have a change that is somewhat controversial, it's a good idea to rerun that experiment later on and see if you can actually replicate its results. That's really the only way I know of to account for novelty effects. Actually measure it again when it's no longer novel, when it's no longer just a change that might capture people's attention simply because it's different. And I really can't understate the importance of understanding this. This can really skew a lot of results. It biases you to attributing positive changes to things that don't really deserve it. Being different in and of itself is not a virtue. At least not in this context. Another problem, seasonal effects. So again, if you're running an experiment over Christmas, people don't tend to behave the same during Christmas as they do the rest of the year. They definitely spend their money differently during that season. They're spending more time with their families at home. They might be a little bit kind of checked out of work. So people have a different frame of mind. It might even be involved with the weather. During the summer, people behave differently because it's hot out. They're feeling kind of lazy. They're on vacation more often. Maybe if you happen to do your experiment during the time of a terrible storm in a highly populated area, that could skew your results as well. So again, just be cognizant of potential seasonal effects. Holidays are a big one to be aware of, and always take your experiments with a grain of salt if they're run during a period of time that's known to have seasonality. And you can determine this quantitatively by actually looking at the metric you're trying to measure as a success metric, be it whatever you're calling your conversion metric, and look at its behavior over the same time period last year. Are there fluctuations, seasonal fluctuations that you see every year? And if so, you want to try to avoid running your experiment during one of those peaks or valleys. Another potential issue that can skew your results is selection bias. So it's very important that customers are randomly assigned to either your control or your treatment group, to your A or your B group, right? But there are subtle ways in which that random assignment might not be random after all. For example, let's say that you're hashing your customer IDs to place them into one bucket or the other. Maybe there's some subtle bias between how that hash function affects people with lower customer IDs versus higher customer IDs, and that might have the effect of putting all of your long-time, more loyal customers into the control group and your newer customers who don't know you that well into your treatment group. And what you end up measuring is just a difference in behavior between old customers and new customers as a result. So it's very important to audit your systems to make sure there is no selection bias in the actual assignment of people to the control or treatment group. You also need to make sure that that assignment is sticky. So if you're measuring the effect of a change over an entire session, you want to measure they saw a change on page A, but over on page C they actually did a conversion. You have to make sure they're not switching groups in between those clicks. So you need to make sure that within a given session, people remain in the same group, and how to define a session can become kind of nebulous as well. Now, these are all issues that using a established off-the-shelf framework like Google Experiments or Optimizely or one of those guys can help with. You're not reinventing the wheel on all these problems. But if your company does have a homegrown in-house solution because they're not comfortable with sharing that data with outside companies, it's worth auditing whether or not there is selection bias or not. One way for doing that is running what's called an AA test. So if you actually run an experiment where there is no difference between the treatment and control, you shouldn't see a difference in the end result, right? There should not be any sort of change in behavior when you're comparing those two things. So an AA test can be a good way of testing your A/B framework itself and making sure there's no inherent bias or other problems, for example, session leakage and whatnot, that you need to address. Another big problem is data pollution. So we talked at length about the importance of cleaning your input data, and it's especially important in the context of an A/B test. What would happen if you have some robot, some malicious crawler that's crawling through your website all the time, doing some unnatural amount of transactions, and that robot ends up getting either assigned to the treatment or the control? That one person, that one robot, not even a person, could skew the results of your experiment. So it's very important to study the input going into your experiment and look for outliers and analyze what those outliers are. Should they be excluded? Are you actually letting some robots leak into your measurements, and are they skewing the results of your experiment? This is a very, very common problem and something you need to be cognizant of. There's malicious robots out there. There's people trying to hack into your website. There's benign scrapers out there. They're just trying to crawl your website for search engines or whatnot. There's all sorts of weird behavior going on in a website, and you need to filter out those and really get at the people who are really your customers and not these automated scripts. And that can be a very challenging problem, actually. Yet another reason to use off-the-shelf frameworks like Google Analytics or whatnot if you can. All right, and we talked briefly about attribution errors. If you are actually using downstream behavior from a change, that gets into a gray area. You need to understand how you're actually counting those conversions as a function of distance from the thing that you changed, and agree with your business stakeholders up front as to how you're going to measure those effects. You also need to be aware of, if you're running multiple experiments at once, will they conflict with one another? Is there a page flow where someone might actually encounter two different experiments within the same session? If so, that's going to be a problem. And you have to basically apply your judgment as to whether these changes actually could interfere with each other in some meaningful way and actually affect the customer's behavior in some meaningful way. All right, so again, you need to take these results with a grain of salt. There is a lot of things that can skew your results, and you need to be aware of them. So just be aware of them and make sure your business owners are also aware of the limitations of A/B tests, and you'll be okay. So remember, the short-term nature of an A/B test subjects it to a lot of limitations. You might be just seeing novelty effects or seasonal effects and whatnot. So if you're not in a position where you can actually devote a very long amount of time to an experiment, you need to take those results with a grain of salt and ideally retest them later on during a different time period.